Let us work out this problem from rotational mechanics, rod falling on rough horizontal floor. It states that a meter stick is held vertically with one end on a rough horizontal floor. It is gently allowed to fall on the floor. Assuming that the end at the floor does not slip, mind that it is important. Find the angular speed of the rod when it hits the floor. Now, to work out the problem, let me first draw a suitable diagram. This is the horizontal floor, and initially the rod is standing vertically on this floor. Then it is allowed to fall, and while it is falling without slipping, of course, about its end at any instant t, this is the position of the rod when it makes an angle theta with the vertical. At this instant, it is rotating with an angular velocity which is d theta by dt or theta dot, and we have to find out an expression of theta dot as a function of theta. Well, if we look at the various forces this rod is experiencing, then the first force that we can work on is the gravity mg, that is passing through center of mass of the rod, which is obviously at the midpoint of the rod, that is L by 2 above the foot of the rod. The other forces are the normal reaction from the floor vertically upward in, and the third force is force of static friction, which is Fs, I call it, acting from the floor. Now, this problem we can work out from the principle of conservation of energy, as out of the three forces, the normal reaction and static force of friction are not doing any work because their point of application, the foot of the rod, is stationary. The other force is gravity, which is obviously doing work here. So we can apply the particular form of work energy theorem for conservative forces. The gravity being a conservative force, we can say that gain in kinetic energy of the rod is equal to loss in gravitational potential energy of the rod. I write it as gain in PE is equal to loss in KE. I'm sorry. It should be gain in KE is equal to loss in potential energy. Now, gain in kinetic energy of this rod is its rotational kinetic energy, which we write as half I theta dot square, where I is the moment of inertia of the rod about its axis of rotation, which is the horizontal line passing through point of contact normal to the plane of rotation, and I about its end, about this axis through the end for a rod is 1/3 ml square. So gain in kinetic energy is half I theta dot square, and that is equal to loss in potential energy and any loss is initial minus final. So initial potential energy is mgl by 2 minus the final potential energy is mgl by 2 into cos theta. And on simplification we get that putting the value of I, it is half into 1/3 into ml square is equal to mgl by 2 whole into 1 minus cos theta. Therefore, theta dot by simplification, well, obviously here is theta dot square, half I omega square, and theta dot is equal to root under uh, 3g by L into 1 minus cos theta. In our particular question, we have to find out theta dot. Question is find theta dot when theta is equal to 90 degree. It is about to strike the floor. Theta is 90 degree. And therefore, we get the value of theta dot is equal to root under, I put the value of g as 10, 3 into 10 by 1 meter stick, so L is 1 meter into 1 minus cos 90, that is 0, and I get the value of theta dot, which is, well, better I write it in the next step. Theta dot is root 30, which is equal to this is 5 point almost 477 radian per second. That completes my problem, but I would like to follow up this problem in my next video lecture to discuss certain interesting insight into this problem. So please look forward to my next video lecture. Thank you.